Hi guys, I'm Lauren and this is Richard, and we're back with another installment of Tanks versus Zombies.
That's right.
With actual zombies this time.
Also, this time we're going to 412. We're skipping 411 entirely.
Yes.
So,
Do you want to pull up what we had on the end of the last stream? Which is with the...
So we're here.
Yes.
And we have a tank that moves around and shoots and has a maximum shoot rate of, I think it was like 1 per second. You can see whatever that is that you're seeing right there. That's the maximum. So there you go. And it rolls around and it's cool.
Yes, so the little projectiles and the aiming, and so now we're going to get some zombies to incentivize us to shoot our tank.
Right.
Yes.
So we first go to 412. This one.
And were there a lot of changes that we had to make to upgrade it to 412? I feel like there were only a couple, and they're mostly about components. So
yes, there were 2 things we had to change. Nothing's too big a deal, but I would like to call attention. Whoops. Wait, you can't see what I'm doing anyway. Here we go. Put it. Oh, it doesn't matter. I'm not even looking at that screen anyway. There were 2 small changes. I would just like to call attention to them because they're things that are pretty common and they're really easy to fix. But just so you know what they are. Now, where is our project?
right there.
That was convenient.
It's almost like...
Yes, that's the correct one. Almost like I loaded this before, and it's still in the same place. I wish this would be on that screen, but oh well.
It will soon. As soon as it loads, we'll move it over magically. I think it probably popped up in the background if you want to drag it over.
So we have our code up, and that worked. Let's just make sure that we're seeing this right. Here we are. Okay, so can we all right, can we show the code then?
Yep.
All right, so here's the code that we have, and we're going to build it. And as you can see, this is not quite going to build for 412. I did just run that in 412, right? Yeah, I did.
Oh,
all right, so there we go. We got couple errors, couple warnings. I'm going to go to the output window. I find that a little easier to use than the error log for finding errors, oddly.
Yeah. And we can actually make that a little bit bigger so that people can see kind of all the errors at once.
Oh, can we?
I don't know if we can zoom, but as far as just dragging up the device.
I can do that here. This window just seems to scroll up and down when I do that. So I can
thank you, Shelly.
All right. So let's scroll this over a bit so we can see. So we're setting up a lot of things with attached to, like right here, and that is no longer the way.
Oh, okay.
So we're going to change all instances of attack to.
Attack to.
Attached to. I'm really waiting to get to those zombies.
I know.
Attached to will be changed to setup attachment only in our current project because I don't want to do it in 500 places in the engine. Replace all. There aren't that many of them, 6 in the whole thing. And then there's one other issue, which is, can I find it here? Oh wait, this is not even the right window. Anyway. There we go. Oh, it's here. It is.
Oh, Undeclared Identifier.
Right there.
And I think somebody on the forums actually pointed this out to us, which we then updated for 412.
Oh yeah, we may have done that. So we used to be able to get the parent component actor, but now. 1, you don't get it directly. There's a function that gives it to you. And 2, you get the parent component, not the component actor. This is actually more useful. So if you have a child actor component, it's going to spawn that actor. And then that actor can get back to the actor that spawned it. But what's more useful is getting back to the component that spawned it, because you could have an actor with multiple child actor components, and then the actors that they spawn don't know which one they came from. They just know they came from the actor.
Like once our tank has a lot of turrets, possibly with a bunch of turret attachment points or something like that.
Yes, if we had, you wouldn't know which child actor components spawned you. You'd have to fish through them. So this way you get back to it directly, and getting from there to your parent is very easy. You can just get owner. So that's very easy to do if you wanted the functionality we had before, and if you want the functionality of knowing exactly what component you came from, now you can do that. So that's the change there. For formality's sake, I could have sworn I just copied this whole thing. Maybe I didn't.
There you go.
So there you go. Okay, so now
So basically anybody who was working with attaching component hierarchies or with child actor components in 410 will need to make these changes in their projects for 412.
Yes. And there we go. That works. Let's run it. It says we need to rebuild, but I don't think we actually do. And that's coming up. So let's see, where are we? Okay.
There we go.
So we're back in. All right. So let's see. What are we doing in what order? First thing we're gonna do is we're gonna set up some channels. I want to make sure these are all set up. I don't remember which of these we set up last time, but I'm pretty sure we didn't set them all up.
Yeah, I don't think we had any collision because our map is fairly open. Our tank really wasn't having to check for anything. And just to kind of give everybody a little insight into how we decided our tanks and zombies should work is that we're going to do traces between the zombies and the tanks because zombies couldn't run over tanks, but tanks would be able to run over zombies, and we want to be able to set up custom things like that.
Yeah, it's sort of interesting having that asymmetrical collision where one thing will stop, but the other will just keep going. But we thought that would be kind of cool, and it would be appropriate for this type of game.
And also, it's a little bit of a cheaper operation than using, say, capsule collision. Right?
Oh, yes. We don't need to use full physics simulation for this. This is pretty simple stuff. One of the advantages of full physics collision is that everything, it's a complete system and everything works right and looks right. And works together really cohesively. But an advantage to writing your own collision is that you can give your game its own specific feel. And I think for certain types of games, like side-scrollers, for example, this is really, really key to making, the jumping or whatever in your game feel distinct and feel exactly the way you want. So it sort of depends on what you're doing, which one you want to use. So zombie pawns are going to be a thing, and by default, they'll block.
Oh.
We'll get to what that default is in a minute, I suppose. And also, while we're here,
and so the custom channels are just because, for clarity to be able to say, these have the specific response and these have another.
Yeah, and we don't just want to use regular pawn for the zombie pawns. We could use pawn for the tank or something like that, but the zombie pawns are special and they're going to collide in different ways, so we're going to do that. I'm a real fan of using these preset profiles. I love these things. So you're limited to a total of 18 object channels and trace channels combined in addition to the ones that come built in.
Oh.
But profiles, you can have as many of them as you want. So I basically set up the minimum number of channels that I need and then recombine them in profiles. So, ignore this one, overlap that, block this, that kind of thing. So for a zombie, we're just going to use the zombie's general movement, whatever. It's going to be query only, and it will of course be a zombie pawn. That will be the type that it is.
Right. This comment for when we want to go back later and figure out what our zombie general actually does.
Yeah, that'll show up right here in this column. Okay, so what does it need to do? It needs to be, well, it can ignore this and this. It should probably be blocked by these things. It should probably be blocked by pawn because our tank is currently a pawn.
Right.
We'll probably keep that. Don't care. Our tank could have been a vehicle, but it's not.
No, because those come with wheels and a bunch of things that we didn't necessarily need for our little 2D sprite tanks.
So the question is whether or not zombies can move through each other. I'm going to say for now, no. This will mean that until we write some proper AI for them, they'll bump into each other, and if they're moving in different directions, they'll just deadlock.
I'm okay with that, though. I want some zombies to just kind of...
Yeah, and then you can just fire a missile into the crowd, and it'll be easy. If they don't block each other, they can kind of group up, and there can be like
one solo zombie just stacked on top of itself. Yeah.
Yeah. So I'd prefer that they get stuck rather than that they do that just for now. But if you don't like that, you could easily just put them over here to ignore. You might even do ignore or overlap, and then if you detect that two zombies are close together, you just put a little phantom.
Yeah.
Just push them apart a little bit. That's another way to do it. There are lots of ways to handle it, but for now, simplest thing possible. All right, so that's good, and I don't know that we'll get to it, but just in case, typing into nothing. Let's try that again. The missile in flight will be of type missile. and it will, let's see, it will need to stop on world objects. It will ignore pawn because that's the tank that fired it.
Right, you don't want to kind of get caught on itself, what might happen or something.
Yeah, well, because you're going to spawn it from the turret, so it's already sort of in/on top of the tank.
Right.
So yeah, there's no need for that. It won't collide with itself, but it will collide with zombies. And there you go. I think that's about it. Oh wait, just for a second. Also, zombies need to collide with it. If you have, so this is one little trick about collision that I thought would be worth bringing up. If you have two things that are going to collide with each other, they will take the lower response. So you have 3 grades of response, which is block, overlap, and ignore.
So if at least one thing has ignored, then the whole collision will be ignored no matter what
Then the
the other
collision is
says.
kind of ignored. Yeah. So you want to be a little bit careful about doing that sort of thing. Oh, and while we're here, this has to be on query. It can't be on no collision, or this will definitely not work. Okay. So that's pretty good.
And
That's
that will
our
just kind of
collision setup.
automatically save because that's how the project settings work. So.
Oh yes, that's right. All right. So no different so far. Now we created some content, and I'm not going to go through the process of recreating the content this time. We did that before, and it's not changed.
It's still the sprite sheets, but we will make everything available through the forums so that you guys can kind of take a look at the assets. We made a little sprite sheet for the zombies so they kind of will have a really, really rough walking animation with one hand out and the other hand out, so they can kind of, I don't know, walk or chase you or dance. I mean, whatever you imagine your zombies doing.
So we have the green zombie sprite sheet here. Let's get that into our content folder. Open that up. Sprite, you can see what I'm doing. Sprites. Oh, and I actually moved around a fair amount of content here.
Just organizing all the things.
Yeah, I reorganized it so that so the sprites folder, and you know what? I'm gonna, since we don't have the zombies in yet, I'm gonna close this and go back to that window there. So, yes, what we ended up doing. Ooh, I'm about to do something that is a bad idea. Let's not do that way.
Just copy those in parallel. And
we'll
then
just drop these in, and we'll change them in engine. You really don't want to do a lot of moving assets around while those assets are in use outside of the engine. That's asking for assets not being found and that sort of thing. Whereas moving them around in the engine is pretty straightforward, and the engine is very good about
being able to fix up your redirectors or when you rename something, it's just aware. So that's why hard coding asset reference is something we try to avoid in tutorials, things like that.
Yeah, so we're going to continue to avoid that here. So as you can see, like all the stuff
is there, just a little bit more organized. So so the one we put up on the forums, we'll just have the green zombie and the tank sprite sheet folder, and then
we'll have that reorganized. For now, I'm not even going to bother moving it here because it works, and we'll we can fix that up later. All right, so just to make sure we're still sane, yes, we're still here. And the missiles don't blow up on the tank.
Right. Or, sort of in midair.
So we need to create a zombie. Let's get to that.
Zombie alert! Yay! I knew that was coming. I'm super excited. We'll try to give as many opportunities for that as possible. So they're also going to be pawns because we're going to possess them with some AI. So we're not going to control them. We're going to have some AI to control them.
Almost like if you think of a bot match.
Yeah.
Kind of like a bot, but in this case, the bot is also a zombie.
Robot zombies? That's the next stream.
All right, so I'm just going to put this in a folder, enemies, just
a little organization in case we do have robot zombies in a future stream.
Yeah.
Or other tanks or something like that.
All right, and that should go into our current instance of Visual Studio.
Just gonna compile really quick. But yeah, I know that you can add classes through Visual Studio, but I prefer this because it's nice to have the boilerplate and just have it kind of run through one compile for you and be ready to go.
Oh yeah, I always do it this way. It's
there's a zombie.
It's pretty easy. So let's and while we're here, where's the other one? Oh, it's here. So I'm just going to open up the other one in parallel so that I make sure that I'm following the...
We just have to open the source if it's going to try to rebuild it.
Yeah, just tell it no. And then we'll come over here and... Oop, it's not there. Well, whatever, the source is still here. That's right, because you would have to rebuild the intermediates from there, which I don't have. All right, so let's open...
We're just checking our work, because we prototyped a lot of awesome zombies, which I feel like we had some really awesome zooming around ones at some point, too.
Yeah, at some point we did have that, yeah. We're not going to do that one today, but...
No, slow zombies are my favorite kind of zombie, because you can walk away from them.
No, I don't want to download it. Thank you for telling me about plugins. Move over here. All right. So we're going to set up a lot of stuff in here. Normally, you could just do this in a blueprint, and that would be like a pretty...
Because we're just changing a lot of properties for the most part.
We're mostly setting a lot of properties. It's a pretty standard way to do it, but we're doing this in C++, and it's totally acceptable to do it here.
Well, the other thing, too, is if you go to... When we go to the header, you'll see that we can make these maybe like blueprint read-write variables, and so then you could set your defaults in code and then make it something that you could tweak later in blueprints if you wanted to.
Yeah, and also stuff like this, you just don't want to set this every time you make a zombie blueprint.
Keep talking, I'm good.
Stuff like this auto-possess AI, you probably want this. This is probably the default you actually want for all of your zombies ever. Right. So there's really no benefit to having to do it in Blueprint. There's just a chance that you'll forget to do it on some zombie type and then wonder why your zombie isn't working right.
So what is the option that you actually toggled, the auto-possess AI? Like, what are your other possibilities?
Sorry, so I had those up for a second. Let's put them back up. So
that was when I was throwing my microphone across the room.
Disabled, only when placed, only when spawned, or when it's placed or spawned. So I want this thing to be possessed by AI pretty much any time it shows up in the world, no matter how it got there. That way I don't have to write extra code to do it, and I don't forget. So zombie's gonna have some health, which I don't think we're actually using yet. I think we set the missile to destroy them instantly, but
at some point the zombies may want to know how healthy they are, or maybe they'll just lose health over time because they're decaying and becoming more and more zombie-like, which would be cool too.
Kind of like Gauntlet, except they're like the players this time. So zombies are gonna have... I'm not trying to make this a stealth zombie game, but I ended up giving them vision and detection because I wanted to have them just walk slowly in a straight line until they see you and then speed up and kind of rush at you a little faster. Yeah, it's a little creepier too. It's a little more of the feel, like Walking Dead or whatever, where if they don't see you, they just sort of shamble around, but then when they see you, they speed up and they've seen you. Yeah.
So actually, we didn't go to the header to set these up as properties yet. Are these all mostly float?
Well, these are floats. You can see with the F designation, and yeah, this won't compile if we just do this. We're gonna have to go and set these up as properties. Zombies need to have a max turn speed, of course. I want them to have a little curve to their walk instead of just sort of snapping straight at you and pulling in. That doesn't quite feel right.
Yeah, because even though they're gonna speed up a little bit when they see us, they're still pretty kind of slow plodding zombies.
Yes, and in fact, here is our speed up. So they don't quite go double speed.
Yeah.
They increase, thank you. They increase about 80%. And for their attack, we're going to have them, they automatically hit you if they're within range and they choose to attack.
Okay.
The range is going to be short enough that there's no reason why we would have a collision check. They're not using a ranged attack.
So they're not going to be standing off in a field somewhere going, and then your tank being damaged.
They could if we set this attack distance high enough. I mean, that would be why you don't do that.
Right.
But yes. They technically could hit you through walls or anything else as long as you're within distance. So we're going to set the distance to be short enough. And this is the distance from their center to your center to make the calculation easy. So you have to bear in mind that the width of the zombie's body and the width of the tank are both included in this number.
Right. So if we were to make some giant mega tank, it'd be better to make this a variable that gets calculated off of our tank size or something.
Yes, yes. If we had variable size tanks, we would definitely want to deal with that. But as it is, we try to keep the math simple so that we're not writing complex code to solve simple problems. And of course they need an attack rate. You can have them hit you every frame. If a zombie were on fire, I would probably have him I would probably give him a DPS, just like a damage per second, and just every tick it would do that much. But in this case I want discrete individual
attacks,
smacks on the car hood like Dustin Hoffman in Midnight Cowboy. If you, I don't know. It's the I'm walking here is from that. It was a shot they did in New York City, and someone just almost ran into him for real, and he stayed in character and just started slamming the hood and yelling at the guy. And it's in the movie. It's not an outtake.
So just imagine the zombies.
Yes, and Dustin
smashing on
Hoffman.
your
Okay, so that's good. Oh, well, it's not good because we didn't actually write any of the. Yes. let's remember to do that. So let me get to that. So wait, there's a close all but this, right? Yes, there is. No. Here we are. Here's our H file. Okay. So I just because I don't want to type 15 of these. All right. These are. I don't know. You could make these. I think actually, did I make these public or protected? Let's see. Yeah, I made these.
I feel like protected is a pretty good practice for these because you want, different types of zombies to be able to set their own sight distance and things without a bunch of, going through functions to do it. But you don't want the tank to be able to change the speed of a zombie.
Yeah, I certainly don't want other game classes also, coming in and modifying this stuff. So yeah, protected is pretty good. I agree. All right. So we're gonna go through these. I know I just pasted them all at once. We're still gonna go through them. It's just faster than me typing them while explaining them.
Yeah.
All right. So there's one that we didn't talk about. This is going to be a property that we do set in Blueprint because this is going to be an asset.
Mm-hmm.
When the zombie hits you, your screen shakes because that's cool.
Ooh, camera shake is fun.
Yes, and if we had like proper art support, we could do this. You can actually animate a camera shake. We're just going to do oscillation and hope that the screen sort of moves around enough that you don't notice that it's really periodic, predictable motion, and it'll look fine. But with an artist, you could get a really good jagged shake. Like when someone bumps into somebody holding a camera. All right. So a lot of these I clamped at 0. Health, actually, you might even want to clamp at 1. Although you could do the thing where a weapon doesn't do any damage, but it does stun something, but it will kill the zombie because it'll check his health and see it's 0. Just like that Zelda thing I talked about with the bats. Way back in match 3 for no reason. And when I was writing the health, I realized that I could code that exact thing here, so I did.
Actually, a camera shake was making me think of match 3 a little bit too, because we have little camera shake.
Oh, that's right. Yeah, you should always have camera shake. Camera shake adds so much to things. All right, so sight angle. Again, I mean, it's in degrees. I pretty much just went through and did this so that I could put comments on it so it would show up for artists.
So is there a reason that we didn't make the variables all like Blueprint read write so that we could actually maybe change the speed, on some sort of zombies get food and so they're able to chase you faster or something like that?
We could do that. You can shoot zombies with something to slow them down, something like that. We could do that. Normally, I would do that by having a buff that stays on the zombie so that when the buff's removed, I can get back to your original value. But one other reason that I was thinking about doing this, we didn't actually do this. Well, I did, and then I undid it because whatever. Was things like sight angle. We're really only ever going to use the cosine of sight angle as degrees, which means every time we use it, we're going to have to convert it to radians and then get the cosine of that. If we didn't want to do that calculation constantly, we would take sight angle whenever it changes and cache it to a separate.
To access it and change it and do that math once.
Yeah,
and then okay.
There would be another variable like this that you can't see anywhere that does this, and then there would be functions for setting it, and then we would hide it so that you can't get to it any other way.
Right.
But we didn't. So instead, I just made it so you can't change it on the fly, as that would mess up the caching, even though we're not doing the caching. So in general, though, the reason I would not do it is just for buffs. But if you want all your changes to be permanent, for the rest of that zombie's life, then you could go ahead and just modify it, and it would actually be fine. So we could make these read-write as it stands, and I think we'd be fine.
Yeah, and then the clamp min is something that's good to note that, if somebody enters in something like a negative attack cooldown, it just won't be accepted even if it is in the editor.
Yeah, it'll just bring it up to 0. There's also a clamp max, and even for integer variables, you still It's still 0.0. You don't put the F designation on there for floats like you do in C++. They just always look like doubles regardless of what the thing actually is. There's one other property that we use. So we have the attack cooldown. That was a zombie bird. We have the attack cooldown, and along with the cooldown, I mean, the use of that is knowing when the next time the zombie is allowed to attack is.
Okay.
So we're gonna put this here. I'm putting it as transient. That doesn't really matter for this project, but for a network project, if you don't want that to be sent over, if you want that to be calculated locally, you can do that. Or for a project with save games, this basically keeps it out of serialization.
Gotcha. And the visible instance only is just because you don't want to be able to change it. It's dependent on the attack cooldown. It's just so you could check your work to make sure that, if the game is not doing what you expect or something, you can take a look at the attack available time.
Yeah, exactly. It's just for while playing. And you can, this one I did actually make blueprint read write, just in case you wanted to do something that resets a zombie's cooldown, or, I don't know.
In blueprint logic, right?
Yeah, or you have maybe a tank weapon that prevents the zombie from attacking for 10 seconds or something like that.
Little stasis bubble or something.
Stasis bubble, or music box, and the zombie can only dance. He can't attack.
Oh my goodness, so many features that we're going to probably put in some future version of.
We might. We did do a lot with match 3, so we might. Anyway, yes. Oh, and I put them all in category zombie, so they're, easy to find. All right, so that pretty much covers that. Let's see. Oh. Now these two are going to be private for a reason. So these are all protected.
Mm-hmm.
These are going to be private. So for those who are a little new to C++, public, other classes can just look at it and modify it and whatever, it's fine. Protected, this class can do it, and child classes of this class, like derived from this class, can do it. Private, this class can do it, and that's it. Even derived classes. So if I made something that inherits from zombie, even that can't directly touch this variable.
Right. It is good to note, though, there's that metadata that's for blueprint protected. So if you have rules for other C++ classes, you can have different rules for blueprint access.
Yes, that's true. You can actually make it more accessible in blueprint than in C++. So these are like this because we're going to get these. We're going to get these only from accessor functions. So when the zombie finds a target that it wants to attack, it will assign the target actor. It will store that, and then if that target is a tank, it will cache a pointer to the tank here. So this way we don't have to constantly cast things to a tank. We can just ask it to give me your target as a tank, or just give me your target, regular.
So if we did have that music box or something, the zombie's going to smash it, that would be target actor, but not under target tank.
Right. And those functions will be public. So other classes do have a way to get at these variables, but not a way to do just whatever they want with them.
And that's because if we had the set target, and we only set the target and not the tank, accordingly, then you would have that mismatch. So that's why you can't reach in there and change it directly, right?
Yes,
Yeah.
that's exactly right. All right, so let's go in, and these are actually exceedingly simple functions. Oh wait, did I put the set target? I didn't put the set target function. We need a set target function, or else these variables are going to be pretty useless. You
will get them, and they will be null, and
yes, you don't have a target ever.
The zombies will mull around forever. Actually, they probably won't. They'll just kind of stand there.
No, they'll mull around.
Yeah.
These zombies, they move at minimum walk speed and at maximum run speed. So even with no input, they continually move forward. So yes, they will. All right. So let's go in and do these functions. These are super. Oops, am I in this? I'm not in this window.
Oops, I think that was.
Oh.
Right in the middle of.
He's just going. Doesn't have a target.
I saw, he's
just going.
Without
zombie.
any input. Oh my goodness, that's amazing.
Yes, that's what they do with no input. That was amazing. That was
charge
great.
off the screen and chase us.
Okay, so when you do this, it's pretty simple. Target yes, that one. The target actor equals the new target, and the target tank. So simple. We just cast that new target. There you are. to being a tank. Now, if it's not a tank, the cast function will come back null, so target tank will be null.
So you don't have to do any checking or anything. It just will handle it for you in the cast.
Yep. Oh, and then so then we need to do our get functions, and those are one line. Oh, it did that for me. I have different settings on my ones at home and my desk, so not used to that. Return target tank, and the other one is pretty predictable.
Actually, would the first one just be return target
It sure would.
actor? And then there we go.
Now, if you want the tank, that's that one.
Yes.
Okay. And this is a pointer, and this is a pointer to another type. Which reminds me, we should probably... Oh, there we go. We need to know about not tanks, but tank.
That's true, because we have to know our target. We didn't in the header, right? Because it's just the pointer.
Yes, in the header, we only need to know that's a class, just so you know, C++, that's going to be a class, I promise. And if I don't fulfill that promise, it will be a linker error. But if I don't tell it in advance, it will be a compile error. Okay. So where are we here?
Let's see. Are we going to have something to visually represent our zombie? I think we were talking about flip books and the little...
Oh, yes.
Because right now the pawn, because we started with a regular pawn and not, a default pawn or a character, it really has no representation. It would just kind of be...
Yes, let's get that back in. And our zombie is going to be, we're going to put the paper flip book on him in Blueprint. We could do it in code, but in this case we'll do it in Blueprint, and then the Blueprint will handle animating it. This is sort of a normal workflow because that way you put the artist in control of all that kind of stuff.
Yeah, we could make the flipbook component code component just to say like all zombies will have some flipbook you could set.
Oh yes, yeah, that would be just as easy to do. I don't think we actually did that. Let me see if we did. Oh, we might have actually done it that way. No, I might have just. I think I did it that one way, and then I stopped doing it that way. So I had it referenced in the class, but not actually used. I think I did it that way initially, and then I decided just to put it all in there.
In Blueprints, yeah.
But yeah, it's absolutely right. It would work either way, just fine. They're equivalently good solutions.
Let's see, it should be there in our all classes. If you
Yep.
just search for zombie.
There we go. And I'm going to name the zombie BP, just so that we can distinguish it from zombie, the C++ class. Yes.
Pause of implying it's C++, yes.
All right. Wow, okay, that's
It didn't know which module
not where I would have opened that, but okay.
So if you were to show inherited variables with the little I drop down there on my blueprint,
sorry,
in the
where
top
are you?
right corner of the tab.
Sorry, I'm lost.
That's okay.
You wanna...
Here in my blueprint, you can show your inherited variables, and
Oh,
so then you
okay.
can see all of the your health and all of that you added.
Yeah. So let's go to. Whoops. No, I'm sorry. We're in viewport. We're in the right place. So I want to add in that paper flip book. Yeah, there it is. The first one. Okay. And now is the part where those assets are going to be useful.
Again, we are going to hand over the assets so you guys can make your own zombie flipbook or just use the one that we created ahead of time, but saved us a little bit of time so we can get right to the zombies chasing our tank.
Do we roll them? Is that how we get it? Yes, we do. Okay, and I think this can just be the default scene route. We don't really need...
Yeah, and maybe you can
Ooh.
put the camera in top just to
Hey,
check.
buddy. Yes. Oh, yeah, the camera in...
There we go.
It's not showing up here, but it is
Yeah,
there.
I can change it back to lit and work on my microphone. One of the two.
Oh, well, we're in wireframe, so...
Yeah.
Yeah, lit or unlit. Pretty much the same. There's no lighting in here.
Okay.
All right. So there we are. And now we can animate that, and we can do events with it. Let's see.
But no sound effects yet because we didn't do any voice capture going. "Rah, rah."
We could have just, yeah.
Just like that.
All right, so this zombie will currently, I believe, do nothing.
Because it doesn't really do anything with its target, or
Put him in there. Is that the right height?
is he just under the world hanging out?
I'm worried. Yeah, I'm concerned he might be under the world. Let me see what height is our. Well, yes, apparently. So let's. Whoops.
That's our tile map. Oh, hi, zombie friend.
Hey, buddy, and he's sideways in a different way than I expected.
Was it possibly when we made him the scene component?
It was exactly when I made him the scene component. Yes, that's exactly what I should not have done. Whoops, put him back. So we're gonna add a scene component because I forgot that the yeah, I felt like I had a scene component there before. I forgot what the reason was.
And that was the reason.
And that was the reason. All right, the reason is that as you can see up here in the transform, it only has scale. Because its location and rotation are determined by
the actors.
By the
Yeah.
root component.
Yeah.
So therefore you can't have additional rotation on top of that.
Yeah.
There we go. Now he's there.
Hanging out. Just
Now our missile will not actually collide with him because our missile's code doesn't use that collision profile that we
right.
set.
And our zombie doesn't have it either.
And our zombie doesn't have it either. So there are two very good reasons.
There's a reason he's just kind of standing there with impunity, like, I know you can't hit me. You don't have a collision profile.
So we would need to give him some collision. I'm going to give him the world's tallest capsule.
Okay. Why tall necessarily? Just because that way.
Oh, that way if we have you know how we have our sprites at different heights and things like that. If we have something that's off by height a little bit.
Oh, that could like possibly stack up and end up with a.
Yeah, or it could be
zombies.
slightly thinner because it's at the top of the capsule. So instead of just make the capsule super tall so that you'll always hit the sides of it, or you'll miss it completely. All right, the capsule's there, and half height, 100, fine.
And the radius, I guess we go to the viewport, we could preview how those look together.
Yeah, let's do that. Well, we probably should attach it to here so it copies the rotation from here. And clear that out. There you go.
And then offset somehow? I feel like we should see
It's not offset.
our flip.
I do think it's odd that we're not seeing our flipbook, though.
It's a ninja zombie.
Hold on. Okay, let's just close and reopen the asset, no problem.
Okay.
Hopefully that'll reset the viewport.
Perfect.
There we go. Let's do this while we can see it. Capsule collision. There we go. And attach it to there. Okay, don't know what happened there, but it's about the right size already.
And then, we should fix the half height again on the
rotation's
capsule.
fine. Yes, the half height. Thank you. That was the thing. Yes, the radius is good. The half height is now just bigger than it needs to be, really. I mean, that's...
Yeah, you can see that he kind of fills up the whole capsule.
Yeah. So, all right. So that works pretty well. So now we have that. All right. So now to control the zombie, now we're on to the brains
We're
part.
going to give brains to the zombie?
Yes.
Brains.
This is the fun part. All right. So we're going to make an AI controller.
Okay.
And I forget if that's a default class or not. So I'm just going to go to it. I'll put this in with enemies too, I think. It just seems like it's
Because it's
inherently
going to control how our enemies work, so it's good to keep them together, yeah.
Yeah. Did I spell it right? I think I did. Yes, I did. Okay.
Shelly with the zoom.
And what did I call it? It was like plain zombie controller or something?
You gave up the opportunity to call it zombie brains?
Why would I do that? Of course. Sorry.
I mean,
I apologize,
missed
everybody.
opportunity.
Yeah.
I could see why you wouldn't want to put multiple A's in there because you'd have to remember later when you were like
Yes.
calling the functions.
Yes, it
How
would
many
get,
A's?
oh. It would it would get a lot less funny when I have to type it every time
You're like,
in
was
code.
it 3 A's or 4? But zombie brains, like spelled correctly, I feel like it's
Maybe
totally reasonable.
autocomplete would save us. I don't know. All right, so let's go check out my differently named file over here, which is plain zombie controller. Boo at this point. All right, and let's get the H and the CPP open so we can see what we're doing.
So this is really a very straightforward AI, right? Like we're not really doing behavior trees or anything like that. We're just kind of looking for a tank, chasing the tank.
Yes, in that sense, we're doing some pretty straightforward stuff.
Yeah.
Yeah, behavior trees feel like you'd want it for more intelligent beings than
And I want our zombies to be like.
this. Although you could certainly use them for this. Wait, yeah, they're not technically in Fortnite. They're not technically zombies, right? They're husks.
No.
They're not.
Which
They're
is a reminder
husks.
that after this stream, you guys should go to the Fortnite game stream.
That's
and
right.
Watch that stream.
Learn about husks and how they're different from zombies. All right, so we're gonna need a yes, we need a tick function in here. Of course we need a tick because every frame this is gonna input. So an AI controller, we haven't done one of these yet. An AI controller is basically it's replacing a player controller. So it's simulating the sort of button pushes and stuff like that that would happen on your keyboard and mouse or your gamepad or whatever, except it's the computer doing it for a computer-controlled character. You could use this for bots in a deathmatch game or something like Unreal Tournament. You just hook this up to a bot and have it act like a player controller. So it's pretty nice that way in that you can think of everything as being controlled by some sort of player. This one happens to be a computer.
I mean, our tank, even if we did like multiplayer tanks, we could have some tanks controlled by AI controllers and some by player controllers, because that pawn will accept both as kind of controllers.
Yeah. They both come from the controller base class, and so they're interchangeable in a lot of places, which is a pretty useful feature.
I think that tick might need an override, is why.
It definitely does.
Is a little grumpy at us.
It definitely does. Okay. So there are two other functions we want to look at. Possess,
Which is default on a controller in general, right?
Yes. Yeah. Controllers in general just have this function. So it's what happens when you take control of a pawn. You get this call, and you can initialize yourself to know what you're doing with that pawn. And then the opposite, when you lose a pawn. This one doesn't actually have an argument coming into it because
you already know the pawn that you're possessing.
One, you already know, and two, you're losing it anyway.
Yeah.
So, all right, so we have those, and just like before with the target as tank thing, I'm going to do a similar thing, and I'm just going to copy this over. Just going to have a cached version of our pawn precast to a zombie. So there's some things that I do in here, like I'll calculate cosine pretty frequently, but casting is something that I don't like to do frequently. Square root and cosine were things that in like the 1990s you would really avoid doing those if you could because they were very expensive. Casting is one of those things that's still a little bit expensive and that you kind of want to avoid doing over and over again if you don't really have to.
To cache where you can, basically.
Yeah. Whereas I don't feel so bad about not caching cosine and square root because they tend to be lookup calls anyway, which are pretty fast. Still better to cache them, but not as important.
Whereas like missiles, you wouldn't cache what you're overlapping because it's going to be different every time. Your possessed zombie or your target tank are going to be fairly stable over the course of the game.
So actually, you know what? Let's do these functions first. I'm going to copy these in. These are super fast and be pretty easy to understand. So we call the unpossessed from the super. Just in general, this is a thing to remember. Always call your superclass version unless you're deliberately preventing its behavior from happening.
Right, and where you call it is important too, right? You want to, in this case, we're calling it first because we're like, handle all of your possession, and then we'll do our specific stuff later.
Yeah, if I wanted to do something else first, I could do that, but in this case, no. Just let it go as normal, and then afterward, I'll be fine.
Looks like.
In fact, in this case, even this get pawn function wouldn't return the actual pawn because it hasn't been through this function that does whatever it's doing.
Right.
So, okay. So that's pretty straightforward.
Yep. I think, though, we've got to rename those two zombie brains.
We do, because I copied them over from the class that was not well named.
It's the perfect opportunity for brain.
It really is. I don't know why I would even have missed it. I must not have been in proper headspace when I wrote that. All right, so.
And then this possession code gets called automatically when something is spawned in or when it's placed because of the code we put on the main zombie, right? That
Yes.
possess on existence.
So, did you say existence? I did hear that.
I decided to make up a word. It's cool.
That's fine. Whatever. We all know what it means, so now it's a real word. All right.
All right. So we're going to check. This is every single frame.
Right. This is every frame. Yes.
If we have a pawn that we're possessing.
Mm-hmm. And we have something that we want to attack.
Okay.
Then, time for violence. All right.
That's the best comment ever. Shamble and attempt violence. Yes.
So, now, by the way, the reason that we don't insist that the target is a tank is, and I think we mentioned this before, in case we want any kind of decoy or any kind of, you trick the zombie into attacking like a landmine or something like that. Or whatever.
Other zombies. Just
or other
zombies turn on each other.
Yeah. So anything like that. So it doesn't have to be a tank. There's nothing inherent to a tank that we need to know about here. It's just that it is a target.
Right.
All right. So direction. I often have to say this one sort of out loud to myself, but it's always end minus start.
Right.
Target minus, destination minus source. Target minus attacker. Whatever it is. End minus start. So we're going to get that, and we're going to get that in 2D. We're going to take the height out of it. Sometimes there might be a little offset because of...
either our capsule height or whatever our actor bounds are.
Yeah, just anything like that. So we're going to take that out. And we only want the X, Y. We don't want the Z. Let's see, can we do this? Okay, we can't quite. Maybe I can scroll over like this to get the whole thing.
Magic.
There we go. All right. Now the dot product, well, it's a bit of a math thing, and I don't really want to go too far into math right now, but the dot product gives you the cosine between two angles. And if you didn't know what that meant already, I probably didn't help you by telling you that. So.
But it's basically if you've got, your direction and then, or the direction to the target and then where you're facing.
Well, any
product,
two directions,
right.
Whatever they are.
But in this case, where your target is and then where you're looking already. And the more those are separate, that will be indicated by the dot product.
Right. So two things pointing exactly the same direction is 1.0.
Mm-hmm.
45 degrees is 0.7. Yes. 90 degrees is 0. And then
exactly
straight back, opposite is -1. So, yes. So you use this with any unit vectors. Your vectors must be of length 1 for this to work. Otherwise, the magnitude of the vectors will get involved in it, and your numbers will scale up or down.
Yeah.
But direction to target, this is a unit vector, and we know it's a unit vector because normals are unit vectors. A unit vector is a vector who has that has a total length of 1.
Right.
And then we also get the way that we're facing, which is the zombie's own forward vector, which conveniently the engine just tells us. And there you go. By looking at those two, we can see our direction toward the target. Now, we don't know if the target's on our right or left from that because 45 degrees right and 45 degrees left, they're both 0.7 because the vectors agree by 70% is, I guess, a way you could think of that. So we do the exact same thing, but now we do it with our right vector. So
if zombie's going like this and going, okay, how far is this to where I'm trying to go?
Right. So based on how much you agree with my front direction and how much you agree with my side direction, I can tell exactly where you are. And to do all that, arctan 2, just some trigonometry, but it gives you give it a delta y and a delta x in that order, and it gives you the angle.
So basically, we know how far off we're facing from it and how far off our right arm is off from it. So now we know how far we need to turn for our zombies to chase the tank.
And the best part is that since we did all of this in terms of our actors forward and right facing vectors, this is a relative angle. It's not a world angle. This is a relative angle to the way we're already facing. So we can just add that directly to our current angle, and that's where we want to be. It cuts out a lot of extra work. Did we ever write zombie AI should attack? I don't think we wrote that.
I don't know if we did yet. How are we going to figure out if our zombie AI should attack?
Okay, so if So we want to know if our zombie AI considers this a good opportunity to make an attack. And if so, we're going to push the attack button. All right, so you can see this is pretty much, this is going to be code that's going to be based on what type of zombie we are.
Right.
Right? Because a zombie that has a ranged weapon or whatever, the zombie has different things that it considers when it's a good idea to attack or not. This is going to be our acting as a player and pushing the attack button. We need to write both of those.
Yeah.
And then finally, this type of zombie does not move while attacking. This zombie controller, the way this thing works is it walks and it stops to attack and then it walks again. It only walks or attacks, not both.
Walk while chasing you.
We could, by the way, do that and it would walk while attacking. That's possible, but we don't want it to. And I'm just going to do this. I'm going to copy this right here.
So we're going to move.
So pretty straightforward. Yeah, we're gonna move straight forward all the time. So that's 1 on the x-axis and 0 on the other 2 axes.
Mm-hmm.
And then this is just a little math trick. Nothing too amazing, but I'm gonna take I'm gonna go from negative 45 degrees, that's 45 degrees behind me, to positive 45 degrees, that's 45 degrees in front of me. And I'm going to map that to the range of 0 to 1. So 45 degrees behind me is 0, 45 degrees in front of me is 1. And I'm going to take the dot product to our target, which was what we said earlier, is how much are you in front of me,
right,
relative to the way I'm facing. So if you're in front of me by less than 45 degrees, if you're really, really in front of me, full speed. If you're somewhere between 45 in front and 45 behind, I gradually slow down to 0 speed, and if you're behind 45 degrees, like you're really, really behind me, 0 speed. Now remember that 0 speed still means walk speed. The zombie will still move even with no input, but just think of this as the player throttling forward on the stick or slowing down a bit.
Okay.
And so, as the zombie turns toward you, it starts to move more aggressively, and if it overshoots or you swing past it, it slows down as it turns around, and then when it gets back and sees you again, rah!
So this is kind of just to give the idea of being able to chase when it sees you, but maybe lose a little bit of awareness when you're behind it.
Yes, and it prevents orbiting, right? If you get in one of those weird cases where it's running at full speed and turning at full speed, and it's just not quite
orbiting zombies.
So what this will do is it'll go out and it'll slow down to turn around and then speed back up as it comes in.
He got speedy. Back up. I have a zombie buddy.
I really like that little guy.
Yeah.
All right. So
I name him something. I don't know what yet though.
So that's pretty simple, and then we're gonna add the rotation input of. See, this is why I like this up here, because this calculation is done.
Mm-hmm.
We just say how far did you want to turn? This far, and it'll tell it the full length of the turn, and then the zombie itself has the limiter for yaw speed. So if you can tell me you want to turn, 135 degrees right now.
And the zombie's going to be like, I will get there eventually.
It'll turn as much as it can,
right,
and you keep telling it what you want. That's fine. All right, so add movement input, you'll notice, unlike add attack input and add rotation input, does not seem to have any problem. Because this is a member of pawn.
Pawn by default.
This is already in here. So that's why I made the others like that. I made them to be similar. Now with this, you can get the pending movement, which is just tell me what the value is, and you can also get the previous movement, or you can consume it. Consuming it means you get the value and the value gets set to 0 and cached off into the previous value. We don't need all that functionality for ours. We really only need consume. We're only going to read it one time. We don't care what the input value was last frame.
There's not going to be any sort of acceleration or anything like that.
Yeah, and there's not going to be any checking to see if we just press the button this frame or if we're holding it down from last frame. Zombie AI is not going to care about any of that. So we're going to make add rotation input and consume rotation input, and that's all.
And also the attack input.
And for attack input, yes. So let's go in here.
And is that on the zombie?
It sure is. So I should have saved that, and I should be in here. All right. Now, in order to, so like I said, those functions were on the original pawn.
Mm-hmm.
We're just going to expand what the pawn has to include those. So, am I in the right place here? Yes, I am.
And also now we can start specifying what zombie AI to use, right, for on the zombie side of things.
Yes. By the way, we also had this function, zombie AI should attack. This is a Blueprint native event, so that we can code it in C++, or if you have, a designer making their own zombie, they can do this in a Blueprint. We're going to do it in C++. But, it's always nice to leave the option. Let's actually do that first.
Okay. That's why it's got the underscore implementation, because that's what you would call, or that's what we've set up in code, and then you can call that from your Blueprint also.
That's right. So going back over here. Here we are. All right, very good. Now. Okay, so once again, we do need to check that we have a target.
Right.
Even though we checked that in the other function, that wasn't here. So we can't make the assumption. We were pretty much doing pretty similar math to what we were doing before in terms of finding, the direction, getting that as a normal, then comparing that to where we're facing. So the zombie's only going to attack things that are in front of it.
Right.
So
you can't attack something that's close to you but behind you somehow magically.
So that's why we're checking that. Now here's where I was saying we could have cached the cosine.
Okay.
So we need the cosine. The only thing that attack angle is good for, the only thing we're ever going to use it for is checking against these dot products, or at least that's the main use for it. So these trigonometry functions in general function in radians. So we need to convert from degrees to radians, because I'm not going to ask designers to start converting things to radians and then typing them in.
Yeah, better to just handle
that's not
that
fun
on
at
the
all.
code side.
And then it's a cosine, so we need to call the cosine function. So basically, we could have cached the answer to these two nested function calls, but we just didn't. Similarly, we could have taken attack distance and squared this and stored it, because we know we're going to compare to distance squared. But we didn't.
Yeah.
We didn't need to. We also could have just asked this not to be squared. It's faster to do the multiply than the square root, I think. I'm not even sure. It doesn't matter.
But we could have this function have inputs of the distance already, because we did calculate that, but that just is.
Yeah. Well, yeah. We could have those, but since different zombies could have different reasons for wanting to attack, or some of them might not care about distance, we just don't bother, and the zombie handles everything all by itself. It makes it as compartmentalized as possible, but you're totally right. If we were trying to do this really efficiently, and I mentioned the 1990s when certain things were slower, we absolutely would have done that.
So many zombies that,
Yeah, we absolutely would have done that if this were an earlier time and these calculations were expensive. We would have just said, all right, just do it this way. And we could even make multiple versions of the should attack function that take different arguments.
Exactly.
So yeah, there are other ways around this, but this stuff is so cheap to do right now that it just doesn't matter. Now we don't check the attack and cooldown, and the reason for this is that the zombie wants to attack. It can't, but it wants to, and that also means that it won't attempt to walk instead.
Okay.
As long as it thinks it's in range to attack, it will stop and wait right there for the opportunity to come up. But it will not continue walking just because it's on cooldown. So that's the only case where it's true, where it's in angle and it's in distance, then it wants to attack. Otherwise, nope, not an appropriate time to attack. It's pretty straightforward. I mean, the code looks kind of big, but it's
just kind of getting that distance and then.
Yeah, it's because we're checking two different things that we end up doing that. Once you break it down into parts, it's actually pretty simple. What's not going to be simple is, well, it will be simple. It'll be bigger, is the zombie's overall AI.
Real quick, let me just check to see how many questions we have, because I know we've got 15 or 20 more minutes.
I'm hoping we can get to that AI part.
I hope so too, because I really want the zombies to chase us. Zombies are not nearly as scary when they're just static. So I think it's the other tab.
It is. It's this one.
Okay.
No, we're good.
Yeah.
Okay.
So back to zombie brain.
Rush. So we're here. No, we're not. We're here and there. All right. So really quickly, the input functions, we'll do those. Those are very straightforward. Pretty much all we need for the rotation is to store what angle we want.
Mhm.
And for the attack button, it's a Boolean. It's whether or not the button is pressed right now. That's all we need to know. So let's get our zombie input over here. I'm glad I have this open because there's a lot of stuff that would take way longer to type out than I really need it to be. There we go. Oh, and I did actually put get functions that I don't think I need. Okay. That's fine. It doesn't hurt to have them. I guess it makes it a little more complete. I didn't call them get pending, but all right.
And these are all
That's good.
protected, or?
Yes, I believe
Okay.
these are all Wait, these need to be public because they need to be called from.
Called by the.
Yeah, they need to be called by outside classes, so these should be public. Are we in public? Come on. Well, we must be.
Yes, there we
Yes,
go.
these are all public. Okay. So, like I said before, it's pretty simple. We can add rotation input, tell it how many degrees you want to turn, and it will add that in. We can get back the current value, or we can get back the current value and clear it. And we need to do that every frame, or else the inputs will just keep adding up. And that is one way that you can get a zombie that moves very fast.
Pirouetting zombies.
Yes, that turns very fast, or that you add its movement input, and it just keeps getting faster.
Caffeinated pirouetting zombies is going to be
Yes.
my new band, by the way.
All right, I like that one. They maybe Indictment of Muffins could open for them. All right, so we need to store, and this will make private. I don't know why I made this private. I think movement input might have been private, but you have enough functions to access and modify this that you don't need this to be.
Right, you don't really want to modify your inputs directly without maybe any sort of sanitization or the clearing, so having them under private is good.
Yep, and yes, I didn't even make these U properties. They never need to be stored or saved or anything like that.
They're just on the C++ side of things.
Yeah,
Okay.
and even in a network game, the zombie's movement needs to be sent across, but its inputs don't necessarily.
Okay.
So pretty simple. Again, uint32 that takes 1 bit is a bool. And that's a float. Okay, so that's pretty much covered. And did we put the functions in here? Yes, we did. Right?
Nope, I don't think we did yet.
Oh, no, we didn't. We didn't. Yeah, we didn't. Okay. Here they are. And we'll blaze through these because they're simple and they're not as cool as the very next thing we're going to do. These we'll put at the bottom of the file just to get them out of the way. All right, so the set functions, they just set. This one doesn't even take an argument because the only thing you can do with the button is push the button.
Right.
The get functions just return whatever the current value is, just in case you need to know, which I don't think we ever do in this case, but maybe somewhere else we might want to know.
Is zombie attacking? Because if so, add terrifying sound effect or something.
Right. And the consume one, we store it, we return that, and then right before that we reset it. Pretty much the same thing. The only difference with the yaw is that we're just adding more and more rotational degrees to it as we go.
Because that is that relative change in degrees. Yep.
Yep. So that's it. That's our input code. It's really simple. It's I don't know. It's faster to explain than to write. Like you just have to write it one time, cut and paste. Pretty straightforward. All right. Now for the delicious, delicious brains. I don't know.
This is where we're looking for our target.
Don't know if we'll get to run this today, but let's hope we do. Right, so this is a little bit more complex than some zombie games might need to be because the zombie cannot know where you are.
Right.
If the zombie automatically knew where you are, like in a lot of old video games, as soon as an enemy spawns, it just starts running its AI, and it's assumed that either it just flies around and is a general hazard, or it attacks you directly, but it knows that you're there if it cares to know.
Right. These are going to be kind of zombies that may or may not be aware of you.
All right. let's go and put this in the
The header also.
yes. And this will be another one of those functions, as you can see by the implementation. This will be another one of those functions that will be overridable in blueprints.
Yeah, you could maybe have a special zombie that was quicker to gain awareness, or maybe was kind of like just stumbled around and never quite was able to find out where people are.
Ooh,
Like
a spider zombie with 360-degree vision.
No,
No?
spider zombies.
Is that not-
No.
Oh, Robert, I'm sorry if you're watching this. All right, so zombie AI implementation. Right, okay, so hopefully that will start to be recognized soon. Okay. So right here we actually, oh yeah, hey look, we do use those get functions
Yes.
that I was saying we didn't need and don't use. Okay.
Good thing we have them.
Yes.
There we go.
Ah, there we go. Thank you.
IntelliSense, like, yep, they exist.
So, wow, I'm sorry for doing that to your eyes.
If you maybe want to like drag it over a little bit to collapse
Yeah,
the
let's-
solution
let's-
explorer.
Yeah, you know what? Let's widen this a bit. And then I can also use the scroll bar.
There we go.
All right, so desired movement is pretty straightforward. If we have attack input, then our desired movement is 0. We don't move while we're
Stand
attacking.
and attack.
And this, by the way, is a little bit redundant with the fact that we don't, that in zombie brains, the fact that we don't, if we press the attack button, we don't go into the logic block that makes us move.
Mm-hmm.
If we wanted to move while attacking, we take out that else, so this logic always runs. And then we could also take out this condition and just always have it be this second part, which is, here you go. So here, we're taking the input value that you gave us. It should range from 0 to 1, and if it doesn't, we will clamp it to that range. And then we will map that to somewhere between walk and run speed. So if you press 0 or less forward,
You will just walk.
walk speed. If you press 1 or more forward, run speed. And if you're anywhere in the middle, we blend the two smoothly. So that way, when you get that between 45 back and 45 forward, you slowly speed up as you turn toward
Rather
the
than
tank.
all of a sudden hitting the gas and chasing you faster.
Yes, rather than just going into a sprint from nowhere, yes. And again, we're only looking at the X, which is the forward on the movement vector. These zombies don't have strafing or
Yeah.
vertical movement, so that's that. And the direction that they're going to move, since this is actually an attempt to get world direction so we can just change their location, is the way they're facing. Makes sense? And of course, we have to temper that by delta seconds.
Which we have. Yeah.
Right, which is an argument into this function. So there you go. So that's your desired movement. Walk speed or run speed times the amount of time that they're walking. That that gives us distance, and then we calculate what speed we want based on angles, or based on input.
We have our original location.
We have our original location, and we have our desired location, which is our original location plus this. Now, the reason I'm doing this is just so that we don't call get actor location a bunch of times. I think we use original. Yeah, see, we use it as soon as I see myself using something in multiple places, it's just a habit to say, okay, cache that answer. Like, don't ask the question twice. The answer's not going to change.
Especially because as we start to adjust things, it might sort of move in the process. So it's going to be like, here's where we started. This
Yeah.
is really the original location.
Yeah, in fact, here we actually need it because we set the actor location and rotation, and this true means to do a collision sweep. So we might not move the full distance if we run into something. In order to find out how far we did move, I go after the fact and check. So I actually do need to have that cached. Right. But just on the principle of not wanting to ask the same question where I know I'm going to get the same answer more than once, I would cache it. But yes, in this case, I actually need it too. Desired rotation is pretty simple as well. We simply see how far we want to rotate, and then we clamp it to how much we can afford to rotate this frame based on our rotation speed and how long the frame was. Our rotation speed times how long the frame was. And that's this variable right here. And again, I calculate it so that I don't have to calculate it twice, once negative and once positive. And the rotator, pitch, yaw, roll, we only want yaw. We don't want them looking up or down or
somersaulting zombies. I'm just imagining all the other
flopping
different
over
possible movement
sideways.
types for zombies.
All of them end up with the zombie turning razor thin and invisible because they're not aligned to the camera axis anymore. Okay, so far pretty simple stuff, and we have this little function, zombie walk, which I'll need to find. Zombie walk, I believe, is a blueprint only function, and it just sets the speed of the walking animation,
Oh, okay.
which is pretty cool. So they actually pump their arms faster when they're running.
Which makes sense, so that you can actually tell not just that they're accelerating faster towards you. But
Are we really limited to 315? Okay. Let's just find that zombie walk quickly. That's okay. It's in the H file.
Oh, so yeah, it's just blueprint implementable.
Yep. It's just a simple blueprint implementable function. And again, this is for artists, really.
Yeah, because
Artists
you could
slash
have
designers.
zombies that do sort of do the regular little flip book motion. You could have zombies that maybe have like a teleport to the next point. And so they kind of fizzle out in a puff of smoke and then come back at their final point.
Ooh, there could be a slug zombie that leaves a nasty slime trail, and you need to know how long that slime trail is.
Yeah.
So we just tell it how long we've been going and how far we've walked. Okay, so
And then
there we go.
check
So
to
we
see
call
if we
that.
have a target.
Yes. Okay, so then we find our target. Because remember, we would have walked even without a target. We didn't check this yet.
Right.
All right. So we find our target. We calculate direction. We do the dot product. This is really common code in any game that isn't a side scroller, like a top-down 2D or a 3D game. Really common code. So you're gonna get really accustomed to getting dot products and stuff. You might even just write your own function, like a blueprint utility function.
It just always calculates from target to where you are, or from where you are to target, and
Yeah, it gives
return
you
it.
the distance and the dot product and the normal and whatever. So this is where we check our attack cooldown.
Mhm.
Pretty simple. And if we pass that and we decide we are definitely going to attack, then this is where we set our attack cooldown. The moment we
Basically
know we're
space attack.
attacking, we just say, okay, so now take whatever our current time is, which is this,
Mhm.
and wait this many seconds past it, so that next time we come here, if it's like next frame, this will fail because not enough time will have passed. Zombie attack.
Would that be another blueprint implementable like animation?
It absolutely would.
Okay.
And I think that's actually where we do our attack.
Right.
Oh no, it isn't. No, it isn't. That's just where we animate in response to our attack. It could be either way though. All right, so we have the attack angle. We must be within the attack angle. We have, and by the way, this is because we didn't check should attack right here. We could have, but sometimes should attack might, you might say the zombie has to get closer than the max attack range before attacking. Something like that. In some games, an enemy will walk up to you and try to attack, and you step back a half step and shoot it, and it swings and misses, and then it steps a half step forward and stops to take another swing. And so you can just sort of gradually inch backward, and it kind of feels dumb. So what you could do is make the attack distance be a lot shorter on the should attack function than it is here. And that's why we duplicated this code. Otherwise, we would have just used should attack right here.
And then we get the
Did I just hit a key? I just hit the wrong key. There we are. Sorry.
And we haven't had a chance to set up the health yet, so we could probably remove that tank target line for now. There we go.
Yes.
And then we get the player
And we
controller
play that camera
and
shake if we have it.
Yeah.
Ooh. Yes. So camera shakes are played on the player controller. The controller is what knows what the camera is doing as well as what the controls are doing, so that's why it goes there. And then another thing that I did here is I only do that if it's a tank, especially because of this line, which we're not getting to today. But the other thing about this is as soon as they hit something that's not a tank, they immediately recognize the error and they set their target to null pointer.
So they can start finding another tank to chase.
So they can just wander around and look for a tank to chase.
That seems good. And so I think that's...
I don't even know if this will compile.
We will try, but I think that's about as far as we'll probably be able to get today, unless there's something that
we
super not compile.
do have the program. We do have the thing already.
Oh, do you have what we...
I did copy the actual finished version here as well.
So we can show that real quick.
Yes, let me just really quickly check here. It's probably just typos. Wow, there are a lot of typos. A lot of whatevers. Oh, well, yes.
Oh, I think you have caps lock.
I might. What makes you think that?
A sneaking suspicion. Oh, so it just didn't know what all of those were.
Yeah, that, and then because I didn't check through to do my
Oh, you're included. Yeah.
stuff like that. Zapumbi dot, however, probably won't help it. Anyway, there might be others like that in there.
We'll make sure we get everything cleaned up before we upload to the forums.
Yes, it's no. The problem is that we've programmed more here than we've been able to show in this time period. But maybe
We get a little sneak peek of what will be there soon. But also next week, Alan Wooler is going to be on doing amazing Alan Wooler things with blueprints and materials. Not to target.
is that what I think it is?
I don't know. What do you think it is?
Oh, whoa, no, that should just be a local float variable.
Oh, because it's in that if statement and your thing isn't nested all the way in there. Right, like your scope.
Yeah,
Yeah.
that's
Because you close the if and then
that's strange.
should zombie should attack be inside of that?
Yeah, possibly. I may have miscopied that block of code
There
when I brought it over.
we go. Hopefully that would.
Yeah, in any case, we definitely want the target to be valid for that. So yes, that should have been in there.
And then
It looks like this might be building successfully.
that'd be
Oh, that's XGU. Never mind. I don't care about that. Building it twice at the same time
It's
probably
fine.
doesn't speed us up. Okay.
And then also switch over to the Twitch channel for Fortnite game at 4, and you can check out all of their new cool news, and it'll be awesome. Then I'll be.
And did we have any other announcements? Let me bring that back.
Yeah.
No, I think you got it. I think you got
have
it.
Very good memory.
Better than
Hopefully
I do.
Alex or somebody puts the link in the stream so you guys have a nice, easy link to access. But otherwise, we show the really quick. The
Yes,
zombies?
let's show the built version right here. Now we do also
Look at
have.
them running around.
See how the one that's run toward me is like really kind of running fast.
The
And
other
this one's
guy's
really
coming.
kind of not. As soon as he sees me, kind of speeds up. And what I'm going to try to do is get them close together so I can get them both in one.
Bam.
Poosh. There you
So-
go.
In the next tanks versus zombies versus tanks, number 5, we'll do the actual collision and zombie exploding and all of that goodness.
Yes.
So thanks for watching.
See you next time.